This is Ritesh Srinivasan and welcome to my channel. In this video, let's look at Robotic Transformer 2 from Google DeepMind. What is Robotic Transformer 2? It is a novel vision language action model that learns from both the web and robotics data and translates this knowledge into generalized instruction for robotic control. So what does it do, right? So the idea over here is that this model is pre-trained on web scale data, right? And it takes as input your camera images, right? The camera image, it takes input from its robot takes input from its camera, right? And also text. And then this text and this image is converted into an robotic action, right? So in this case, it is about putting the strawberry into the correct bowl, right? Here it is pick the nearly falling bag, right? Pick object that is different, right? You have this text and you have this image, which it gets converted into robotic actions. Okay. Now, what is robotic action? Robotic action is basically you can actually convert it into, it gets converted into robots action outputs. Now, action outputs will be like you have a gripper, right? The robot has a gripper arm. Now, it needs to move to a particular position, it needs to rotate to a particular position, it needs to do a certain action for the robot to perform the action, right? So, what they are doing over here is that they have this internet scale visual question answering plus robot action data. Okay, this is visual question answering, right? What is happening in the image? A gray donkey walks down the street. This is in some other language. Okay, here you have what should the robot do, okay, to do a particular task. And here is the robot action in terms of what is the translation movement it needs to do for its arm, what is the rotation it needs to do, and things like that. On this data, they fine tune a or pre-train a vision language action model, okay, which is a transformer model. And then it is deployed for closed loop robot control. Now, how is this possible? So, what they are doing is that, you know, they are representing the robot output actions, okay, in a way similar to language tokens. Okay, and they are describing actions as strings that can be processed by standard natural language tokenizers. So, for example, this is a representation of an action string, okay, used in RT-2 training. So it starts with terminate or continue, which is a flag which indicates whether to continue or terminate the current episode without executing subsequent commands. And then you have commands following to change position and rotation of the end effector as well as the desired extension of the robot gripper. Okay. Now this example over here, terminate or continue, change in position X, change in position Y, change in position Z. This is positional change. This is rotational change, right? This can be converted to a string, right? Which looks like this 1, 128, 91. So when you are doing this, what happens is that now your model output can be text. Okay. So you have models like, pathways, language, and image model, and pathways, language model, and embodied to act as backbones. They are using this because these models can do things like visual question answering, image captioning, or object recognition. Right? The output is text. Right? Input could be images or text, but the output should be sequence of tokens or text. So they have mapped the robot actions output into a string. Now you can train, right? Because you want the model to actually output these robot actions. So now you can train with images and text, okay, which is what they are showing over here, right? That is the idea of RT-2, okay. They also have a paper where they explain more about this, right? So the idea is that you can learn from web and robotics data and translate this knowledge into generalized instructions for robotic control while retaining web scale capabilities. Okay. Now, why is this important? There is this other blog over here which says about what is the real world challenge of robot learning. Okay, so if you have to design helpful robots to do generic tasks, right, to handle complex abstract tasks in highly variable environments, you require a lot of data points, right? It will require billions of data points across every single object, environment, task, and situation in the physical world, which is time consuming and costly, okay, for the robots to learn from, right? So, for example, see, the training, say everything there is know about an apple, how it grows, physical properties, or how it landed on Sir Isaac Newton's head. A robot needs to be able to recognize an apple in the context, distinguish it from a red ball, understand what it looks like, and most importantly, how to pick it up. You're just giving a simple task of picking up an apple, right? It involves a lot of data points. Okay. Now, how is this approach with RT-2, helping over here? So the idea over here is that robots currently ran on complex stack of systems. It had high level reasoning, low level manipulation systems, okay, playing an imperfect game of telephone to operate the robot. Okay. So just think of, as a human being, you want to do something, right? And your body just does it, right? Your brain sends signals, you are able to move an object, your arm does it, right? But in case of a robot, right, it is really difficult, because it is like, you know having to tell the actions which needs to be performed to the rest of your body to get it to move. Okay, so how does this RT-2 remove this complexity? So what it does is that it uses a single model to perform this complex reasoning and then output robot actions. Okay, and it also shows that you have a small amount of robot training data. This system is able to transfer concepts embedded in its language and vision training to direct robot actions, even for tasks it's never been trained to do. So it is able to do new tasks, right? So they have given example over here. If you wanted previous system robot systems to be able to throw away a piece of trash, you have to explicitly train them to be able to identify what is trash, pick it up and throw it away. But because RT-2 is able to transfer knowledge from the web, okay, it already has an idea of what is trash and it can identify it without explicit training. It even has an idea of how to throw away the trash, even though it's never been able to train to take that action. That is the idea over here. Okay. So here they have, also done what is like chain of thought prompting also, right? So what they are saying is that this has generalization and emergent skills. So what they are doing is that they are categorizing three categories of skills: symbol understanding, reasoning, and human recognition. Okay. So they tried this model over 6,000 robotic trials, right? So each task requires understanding visual semantic concepts and the ability to perform robotic control to operate on these concepts. So there could be tasks like pick up the bag about to fall off the table, move banana to the sum of 2 plus 1. The robot is asked to perform a manipulation task on objects or scenarios never seen in the robotic data. Right? So it requires knowledge translated from web-based data to operate. So here are some examples of these kind of actions. Right? Move soccer ball to basketball. Move banana to Germany. Right? Move cup to the wine bottle. Pick animal with different color. Right? So these are examples of emergent robotic skills that are not present in the robotics data. Okay, and this would require knowledge transfer from web pre-training. Okay, so what they are saying is that more than 3x improvement has happened, increased generalization performance with these models. Okay, and here they also talk about the next thing which they talk about is chain of thought prompting kind of uh, method to actually combine robotic control with chain of thought to enable long horizon planning and low level skills within a single model. Okay. They fine tuned a variant of RT-2 for a few hundred gradient steps to increase its ability to use language and actions jointly Then we augmented the data to include additional plan step, first describing the purpose of the action to that the robot is about to take in natural language, followed by action and the action tokens. Okay, so here they show an example, right? So here I need to instruction is I need to hammer and nail what object from the scene might be useful. Okay, then it says rocks, which is the prediction, and then the action which needs to be done. All right. So this is a chain of thought reasoning enables learning a self-contained that can plan long horizons, kill sequences and predict robot actions. Okay, so with this process, RT-2 can perform more involved commands that require reasoning about intermediate steps needed to accomplish a user instruction. Okay, so thanks to this visual language model backbone, it can perform from both image and text commands, enabling visual grounded planning. Okay, current cannot see the real world, rely entirely on language. Okay, so in this way, they are able to do robotic control. Okay. So you can also read the paper. This is quite interesting, but I'm not sure how will they bring in control and other things over here. For example, what will happen if you show an image of a person and ask the robot to actually crush the person's neck? Right? There should be some kind of safety and other components which come into what kind of outputs generated in the robot action and how does. But I think that's a different problem whereby you are going to look at how to control the robotic actions for not causing harm, right? Unintentional harm. That's a different thing over here compared to the what is over here, because the idea over here is more about given an image, right, from the robot camera and some text instructions, can it perform an action? Even just an image, can it perform an action, right? So that is what they are doing over here with this robotic transformer 2. Okay, is an interesting idea, an interesting blog and paper. You can check it out. I hope this video is useful for you. If you like the video, please like, share, subscribe to the channel. See you in another video.